Okay, so now we'll be discussing exercise 1B of AOD, starting with question 1. So fx over here is x power 1 by 3, x minus 1. So to judge whether the function is increasing, to determine its inflection points, area enclosed by the curve, we need to first differentiate. F dash would be equal to 4 by 3 x power 1 by 3 minus 1 by 3. So this would be equal to 1 upon 4x minus 1. So we can see that f increases when x is greater than 1 by 4 and f decreases when x is less than 1 by 4. Since x power 2 by 3 is always positive, this is greater than 0 when x is greater than 1 by 4. Okay, so calculating f double dash x, we get f double dash is equal to 4 by 9 x power 2 by 3 plus 1 by 3 2 by 3 taking common. So within the bracket we'll have 2 plus 1 by x. Okay, and f double dash x will be equal to 0 at x is equal to minus half. So f double dash x is equal to 0 at x is equal to minus half. So this will be our inflection point. Fine. Area enclosed between this graph can be calculated as integration from 0 to 1 x power 4 by 3 minus x power 1 by 3 dx. Fine. Moving on to question number 2. We need to find if line this is tangent to the curve this, then. So the given curve is hyperbola. dy by dx would be equal to slope of the tangent. So dy by dx for the hyperbola would be minus 1 by t square. We already know that the tangent to a rectangular hyperbola xy is equal to c square. Its slope would be minus 1 by t square. Okay, so this should be equal to slope of tangent, slope of given tangent x by a plus y by b is equal to 1, which is minus b by a. So this implies t square is equal to a by b. Now since t square is greater than 0, so a and b needs to be of opposite sign. Okay, moving on to next question number 3. So fx over here is integration 0 to x 1 minus t power 4 dt. Okay, so f dash x will be using Leibniz rule 1 minus x power 4 ka root. Okay, so f dash over here is always greater than 0 within its domain, which is minus 1 to 1. Okay, this implies f is increasing. Okay, so we have been asked whether the function is odd or even. So calculating fx plus f of minus x is equal to so put t is equal to minus t in this, we will be getting one minus t power 4 dt and minus 0 to x 1 minus t power 4 dt. Okay, so this is equal to 0, hence fx is odd. Fine. Moving on to the next question, question number 4. So the coordinates of the points on the graph of the function this. So fx is given, fx is equal to x cubed by 3 minus 5x squared by 2 plus 7x minus 4, where the tangent drawn cuts off equal intercept from the coordinate axes which are equal in magnitude but opposite in sign. So if the intercepts are equal in magnitude but opposite in sign, then the slope of the tangent has to be 1. So calculating f dash y dash, which is equal to 1. So x square minus 5x plus 7. So x square minus 5x plus 6 is equal to 0. X is equal to 3 comma 2. Okay. So we know the value of x, we can always find the value of y. Moving on to the next question, question number 5. So we know fx is equal to a to the power fractional part of a power mod x signum x and gx for a greater than 0, where this and this and this. Then which of the following statements hx? So to judge about hx, we know that hx is equal to fx into gx ln upon ln of a, okay, is equal to ln a to the power fractional part of a mod x signum x into a to the power okay. So this would be this box of upon ln of a. Fine, this would become fractional part of x plus box of x will become x, and ln a would cancel out, so this in turn would become a power mod x signum x. So hx is equal to this. Okay, so simplifying, for x greater than equal to 0, it would become a bar x. For x equal to 0, signum x will be 0, and for x less than 0, it would be minus a bar minus x. Okay, now we need to check whether h is even and increasing if a greater than 1. So if a greater than 1, a bar x is increasing, that's correct. Okay, hx is obviously an odd function. Fine. Moving on to the next question, question number 6. So in this question we need to calculate the interval in which the given function is increasing. So fx is equal to x power 100 plus sin x minus 1. Okay, so we need to calculate f dash for this. F dash x would be equal to 100 x power 99 plus cos x. Okay, so when x belongs to 0 to 1, both of them are positive. Okay, when x belongs to 0 to pi by 2, then again cos x and x power 99 are both positive. Okay, when x belongs to pi by 2 to pi, x power 99 is positive but cos x is negative, but obviously x power 99 would be much greater than cos x, hence f dash x will be positive. Okay, so we can deduce where the function is increasing and where the function is decreasing. Moving on to next question, question number 7. So we've been given fx. So fx is increasing on this. So these are the two simple graphs. Obviously at x, when x is equal to 2, the value of the function is 35, and when x is 2 positive, it is also 35. So the function is continuous, of course. So let's plot the graph. When x is between -1 and 2, it would be upward opening parabola, and after 2 it is going to be a straight line with -1 slope. Okay, so what we can see over here is we can find the minimum point of the graph minus b by 2a. So this would increase from this point to 2, decrease further from 2 to 3, and that would be our answer. F dash 2 is simply non-existence because slope of this line and slope of this line is not same. Slope of the curve at 2 negative and 2 positive is not same. Okay. Moving on to our next question, question number 8. So you need to draw the graph of the following function. So since fx is equal to x square minus x sin x minus cos x, so f0 is clearly -1, f dash x would be 2x minus sin x plus minus x cos x minus plus sin x. So it would be x 2 minus cos x. So if x is less than 0, the function would be decreasing. If f is greater than 0, the function would be increasing. So the graph of the function would be this. Okay. Moving on to the next question, question number 9. Assume that inverse of the function f is denoted by g, then which of the following statements hold good? Okay. So if f and g are inverse, we can say that f of gx is equal to x. Is that fine? So differentiating f dash gx into g dash x is equal to 1. So if f is increasing, this implies f dash is greater than 0. This implies g dash is also positive, since product of these two numbers is positive. Fine. And if f is decreasing, this implies f dash is less than 0. This implies g dash is less than 0, and in this case g would also be decreasing. Okay. F is obviously bijective since it has its inverse, so it has to be injective as well, and g is also bijective, so g is also 1 1 on 2. Okay. Question number 10. For the function fx is equal to ln 1 minus ln x, which of the following do not hold good? Fx is equal to ln 1 minus ln x. Okay, so for commenting on its increasing and decreasing nature, we will need to find f dash x. So it would be 1 minus ln x minus 1 by x. Okay, so if this is less than 0, this will be decreasing. Okay, so this thing is always less than 0 within its domain. So let's solve this. 1 minus ln x greater than 0. So obviously x is greater than 0 if we talk about domain. So this is going to change its sign, my bad. Okay, so if x is between 0 and 1, this is going to vary from minus infinity to 0. Okay, so between 0 to 1, so instead of taking 0 to 1, we can see that between 0 to e, this is less than 1, this is always positive, so this would be greater than 0. The function would be increasing in 0 to e. Okay, also we can see that f dash 1 equal to minus 1. Okay, so if f dash 1 is equal to minus 1, we can see that c is also incorrect. Now calculating f double dash, we get f double dash is equal to minus of ln x upon x square 1 minus ln x square. So f double dash 1 is equal to 0. Okay, so this would be the point of inflection. Fine. Moving on to the next question, question number 11. So we have been given the function fx is equal to x square plus 2 x square and x minus 2 whole square. This is for greater than equal to 1. This is between 1 and minus 1, and this is x less than minus 1. So this is equality over here. Okay, so we can see that fx is continuous. Since x tends to minus 1, this will tend to 3. Sorry, fx is so since x tends to minus 1, this will tend to 1, x tends to minus 1, this will tend to minus 1, x tending to 1 पे this tends to 1, and x tends to 1 पे this tends to 1. So fx is always continuous. Let's draw the graph. This is straight line, this is parabola and parabola. Minus 1, 1. After 1, it is going to be a parabola. Between minus 1 and 1, this is again going to be a parabola, and before that it is going to be a straight line. Okay, fine. So we can answer the options. Is continuous, correct. Is continuous but not differentiable, correct. It is not differentiable at these 2 points. Okay, moving on to the next question, question number 12. So question number 12 says we've given a function fx is equal to cos of tan inverse sine cot inverse x. Cos square. Okay, so let's simplify this a little bit. So let cot theta is equal to x. Okay, so fx would become cos of tan inverse sin theta का whole square. If cot theta equal to x, then sin theta would be equal to 1 upon 1 plus x square का root. Okay, now let 1 upon 1 plus x square का root equal to tan phi. So this would be equal to cos square phi is equal to 1 plus x square upon 2 plus x square, sorry. Okay, so we can see from the following expression that the range of the function is, okay, so this will be maximum when this will be maximum, so this will be maximum when this is maximum, this will become 0, hence 1, and this would be minimum if this would be minimum, which is half. Okay, so 1 minus half, so the range of the function would be half to 1. Okay, clearly we can see that fx is even. Calculating f dash x would be equal to 2x so f dash 0 would be equal to 0. Okay, so C is also correct. Moving on to the next question, question number 13. So both of the given curves are parabola. Either we can write the tangents to these parabola, or we can assume a line which is a tangent to both the parabolas. So solving, we would get x square plus 1 is equal to ax plus b with the first parabola. So if this is a tangent, d has to be 0. This implies a square minus 4 1 minus b is equal to 0, or a square plus 4b equal to 4. Solving this line with the second parabola, we get x minus x square is equal to ax plus b. D is equal to 0. This implies a square equal to 4b. Solving these two equations, we would get b is equal to half and a is equal to plus minus root 2. So we have the values of a and b. We can find the equation of the tangent. Moving on to the next question, question number 14. So fx is equal to integration 0 to pi cos t cos of x minus t dt. Okay. So applying King's rule, we'd get 0 to pi. Cos pi minus t would be minus cos t, and this would be cos of x minus pi plus t dt. So fx would be equal to integration 0 to pi cos t cos x plus t dt. So adding these two equations, we'd get twice of fx is equal to integration 0 to pi cos t to cos x cos t dt. So fx would be 2 cos x integration 0 to pi by 2 cos square t dt. We already know the value of this. Okay. Okay, so Since we've got fx in a very much simplified form, we can comment on its continuity and differentiability. Now moving on to the next question, question number 15. So question number 15. So which of the following equations always hold good in 0 to 1? So for the first part, let's assume fx is equal to x minus tan inverse x. Okay, f dash x would be 1 minus 1 upon 1 plus x square is equal to x square upon 1 plus x square is greater than 0. So f increases in 0 to 1. Okay, so if f is increasing in 0 to 1, we can also see that f0 is 0. f0 is equal to 0. So fx is greater than 0 for all x between 0 to 1. This implies x is greater than tan inverse x. Okay. For second part, again assume fx is equal to cos x minus 1 plus x square by 2. F dash would be minus sin x plus x. Okay, so minus sin x plus x is equal to x minus sin x, which is greater than 0 in 0 to 1. Okay, so if this is greater than 0, then B has to be incorrect. Okay, moving on to third option, let fx is equal to 1 plus x ln x plus square root of 1 plus x square minus square root of 1 plus x square. We can see that f of 0 is 0. Calculating f dash x is equal to x. We already know the differentiation of this. Okay, so this is greater than 0. So we can see that these two terms cancel out, and this term is always positive in 0 to 1. So since f dash is greater than 0, so C is also correct. Okay, moving to option number D, let fx is equal to x minus x square upon 2 minus ln of 1 plus x. We need to calculate f dash x. F dash x would be 1 minus x minus 1 upon 1 plus x. Okay, so on simplifying, we can reduce this to 1 minus x square minus 1 minus x square upon 1 plus x is less than 0. Okay, so between 0 to 1, this is less than 0. If this is less than 0, we can also come to the conclusion for D part as well. Moving on to the next question, question number 16. So question number 16, if we calculate f dash x, we get f dash is equal to 2 minus x upon x cube. Okay, and calculating f double dash x, we'd get f double dash is equal to minus 3 upon x power 4 clearly. So f double dash x is greater than 0 if x is greater than 3. Okay, and f dash is we can see that f dash is 0 if x is equal to 2. So plotting the graph, we can draw approximate graph and interpret the results. At x is equal to 2, the value of the function would be 1 upon 4. Okay, 1 upon 4. Fine. Moving on to the next question, question number 17. You can see question number 17 is quite obvious. So if f double dash is greater than 0, it has to be concave upward. Fx has a relative minimum on -3 to 4. That is not necessarily true. Okay, so for example, in this case, f dash is going to be always positive, but it does not have a relative minimum. Fx has a minimum or -3, 4. Okay, if f3 equal to f of 4, then fx has a critical point on -3, 4. Okay, so if f of 3 is equal to f of 4, so by Rolle's theorem we can see that there would exist a c somewhere between 3 and 4 where f dash c is 0. So fx would have a critical point between -3 to 4. Okay, moving on to the next question, question number 18. So if f has a domain 0 to infinity and has no horizontal asymptotes, so this is not necessarily always true. For example, one of the functions which does not satisfy this is sine of root x. Okay, the second part is if f is continuous is -1 to 1, f of -1 is equal to 4, f of 1 is equal to 3, then there exists a number r such that fr is equal to pi. So yeah, that's pretty obvious from IVT, intermediate theorem. Okay, let's solve part C. So for C part, limit extends to infinity, sine inverse 1 plus 1 by x. Okay, so if x tends to infinity, this is always greater than 1. If this is greater than 1, then it is not in the domain of sine inverse, hence this would not be defined. Okay, for part D, for all values of m belongs to R, the line this cuts the circle this orthogonally. So if the line this cuts the circle, cuts the given circle orthogonally, then the line must pass through center, and the center of the circle is 1, 1. So let's see what happens when we satisfy it with 1, 1. So we get an identity. So for all values of m, this line will pass through its center and cut the circle orthogonally. Moving on to the next question, question number 19. We get to calculate the limit, we can always apply simplest form would be to use L'Hopital rule. Okay, so using L'Hopital, take this x out, differentiating when x is 0, it's 0 by 0 form, correct? So differentiating, we get 0 to x e power t square dt plus e power x square upon 1 minus e power x. So when x tends to 0, it's still 0 by 0 form. Again applying L'Hopital's rule, plus e power x square minus e to the power x. Okay, Now we can put x is equal to 0 and calculate the limit. Okay. Moving on to the next question, question number 19. Sorry, we have a few parts of this question number 19 is still going on. We have few parts of question number 19 left. So for B part, we have given the curve 14x square minus 7xy plus y square equal to 2. Okay, so let's calculate pi dash. So 28x minus 7y minus 7xy dash plus 2y dash equal to 0. So y dash will be equal to 28x minus 7y upon 7x minus 2y. Okay, so if x is equal to 1, this implies y square minus 7y plus 14 is equal to 2, or y is equal to 12, 3, 4. Okay. So L would be 1, 3 and M would be 1, 4. So if we know the point L and M, we can always calculate the slope of the tangents at L and M by putting these points in this equation. Fine. Moving on to the next question, question number 20. So we have been given a function sin power 5x plus cos power 5x plus 1. Okay, minus 1, it's minus 1. X belongs to 0 to pi by 2, which, so we need to calculate where the function is increasing and decreasing. Let's calculate f dash first. So f dash would be 5 sin power 4x cos x minus 5 cos power 4x sin x is equal to 5 sin x cos x sin x minus cos x and 1 plus sin x cos x. Okay, so f dash x is equal to 0 at x is equal to pi by 4. Clearly this will be 0. Also f dash 0 is also 0 and f dash pi by 2 is also 0. Okay, hence by Rolle's theorem we can say that there would be some c between 0 to pi by 2 for which f dash c is 0. Okay, also in 0 to pi by 4 f is decreasing, and in pi by 4 to pi by 2 it would be increasing, because these two expressions will always be positive, and sign of f dash would be determined by this. Okay, moving on to the next question, question number 21. So fx is given 12 power 5 plus 12 x power 5 minus 15 x power 4 plus 20 x cube minus 30 x square plus 60 x plus 1. So we'll need to calculate its increasing and decreasing nature. So first calculate f dash first. So 60 x power 4 minus 60 x cube plus 60 x square minus 60x plus 60, x power 4 minus x cube plus x square minus x plus 1. Okay, so let's calculate its increasing and decreasing nature. So if x is greater than 1, this is positive, this is positive, and this is positive. When x is between 0 and 1, this is positive, this is positive, and this is positive. Okay, And when x is negative, this is positive, this is positive, this is positive, this is positive, and this is positive. So this expression is always greater than 0 for all x belongs to R. So this function is always increasing. Fine. Moving on to the next question. Question number 22. Okay. So we can see that f0 equal to 1, f2 equal to 2. Okay. We can also easily see that f of 1 negative would be 2. Let's calculate f of 1 positive. So f of 1 positive would be 2 again, and f of 1 equal to 2. So we can comment on continuity and monotonicity of the function. Okay. So it would have a unique solution in the domain. Okay. So mixed up 23rd and 22. I guess 20. I read 23rd in the middle of 22. So if f of minus 1 is 2, f of 1 plus is 2, and f of 1 is equal to 2. So the statement 1 is Rolle's theorem is not applicable to fx in 0 to 2. And statement 2 is f0 is not equal to f of 2. We can see f0 is 1 and f2 is 2. So second statement is obviously false. Fine. Now moving on to 23. So fx is equal to ln of 2 plus x minus 2x plus 2 upon x plus 3. Okay, so we need to calculate the solution of fx is equal to 0, and we need to comment on its monotonicity. Okay, so let's calculate f dash. It would be 1 upon x plus 2 minus 4 upon x plus 3 का whole square. X square plus 2x plus 1 upon and this would be greater than 0. We can calculate by drawing wavy curve where minus 1, minus 2 and minus 3 are your critical points. Okay, so moving on to the next question, question number 24. Yeah. So let's see. Question number 24 is, we've been given a polynomial fx is equal to x power 7 upon 7 minus x power 6 upon 5 upon 5 minus x power 4 upon 4. So let's calculate f dash. So this is similar to question number 21, I guess. Yeah, x power 6 minus x power 5 plus x power 4 minus x cube plus x square minus x plus 1. So when x is negative, this entire thing is going to be positive. When x is greater than 1, this is positive, this is positive, this is positive. When x is between 0 and 1, this is positive, this is positive, this is positive, this is positive. So f dash x is greater than 0 for all x belongs to R. Moving on to the next question, question number 25. The function fx is equal to ln x is increasing in 0 to 10, and gx is equal to 1 by x is decreasing in 1 by 0 to 10. So we can easily draw the graphs. This is ln, which is always increasing. Okay, and y is equal to 1 by x would be parabola, which is decreasing in 0 to 10. So that's correct statement. Okay. If a differentiable function increases in the interval a to b, then its derivative function decreases in the interval a to b. Okay, so we can consider the example of say e power x. So e power x is always increasing in a and b, but its derivative again e power x is not decreasing, it is also increasing. So second statement is not necessarily true. Moving on to the next question, question number 26. We've been given a paragraph. So paragraph for question number 26, 27 and I guess 28 as well. Yeah. So three questions for this paragraph. So moving on to this paragraph, we have given fx is equal to x 2 to the power minus x. So calculating f dash x, we get f dash x is equal to 2 to the power minus x 1 minus x ln 2. Okay, so f dash is greater than 0 if x is less than 1 by ln 2. Okay, so f increases when x belongs to minus infinity to 1 by ln 2 and decreases if x belongs to 1 by ln 2 to infinity. Let's calculate f double dash for this. So f double dash would be 2 power minus x ln 2 x ln 2 minus 2. So let's plot the rough sketch for the graph of this function. F of 0 would be 0, maximum value would occur at x is equal to 1 by ln 2, and at x is equal to 1 by ln 2, let's say the value of the function would be 1 by e ln 2. Okay, so this clarifies first 26 question and 27 question as well. So this equation fx is equal to k would have two distinct solutions only if k is less than 1 by e ln 2. Okay, moving on to question number 28. This would answer our question number 27. So moving to question number 28. So question number 28 says we have to calculate integral gx from 0 to 1 by ln 2 minus 1. So we also already seen that fx is increasing in minus infinity to 1 by ln 2. So the maximum value of gx would occur when t is equal to x plus 1. So gx would be equal to f of x plus 1 is equal to x plus 1 2 to the power minus of x plus 1. Okay, now we need to find the integral 0 to 1 by ln 2 minus 1 x plus 1 2 to the power minus x plus 1. So for this integral we can use a by parts integration, considering this as the function to be differentiated and this function to be integrated, and applying the limits from 0 to 1 by ln 2 minus 1. Okay, moving on to our next question, which is next paragraph, comprehension 2. So we'll start with question number 29. So limit x tends to 0 positive gx. So limit x tends to 0 positive x ln 1 plus 1 by x. When x tends to 0 from positive side, this is of the form 0 into infinity. So let's convert this. So this is infinity by infinity form. Now we can apply L'Hopital's rule. Limit x tends to 0 positive 1 upon 1 plus 1 by x into minus 1 by x square upon minus 1 by x square. Okay, so when x tends to x tends to 0 positive, this will tend to infinity, and 1 upon infinity will be 0. Okay, moving to question number 30. So we need to comment on the maxima and minima for the function fx. So when x tends to 0, limit x tends to 0 fx. So when x is 0, it is infinity to the power 0 form. Limit can easily be calculated. Okay, and when 1 plus x power x, x ln 1 plus 1 by x. So now it is 0 into, when x tends to 0, it is 0 into infinity form. So we can calculate this limit. We have already calculated this limit in first part equal to 0. So y would be equal to 1. Okay. We can also see that limit x tends to infinity fx is equal to, when x tends to infinity, this will tend to 1. This would be of the form 1 to the power infinity. So e power 1 would be our answer. Okay. Also f is increasing for all x greater than 0. We can see that it can also be easily verified. Fine. Moving on to the next question, question number 31. So limit n tends to infinity, f of 1 by n, f of 2 by n, f of 3 by n, f of 4 by n. Okay, this would be, let L is equal to, L is equal to pi k from 1 to n, 1 plus n by k and k by n, k power 1 by n. So this is f of 1 by n plus into f of 2 by n into f of 3 by n dash dash. Okay, so now for simplifying, we'll take log ln n would be equal to 1 by n limit n tends to infinity summation k from 1 to n ln 1 plus n by k to the power k by n. Okay, so converting it to the limit as a sum form, we get limit n tends to infinity 1 by n summation k from 1 to n k by n ln 1 plus 1 upon k by n. Okay, so this would be equal to integration from 0 to 1 x ln 1 plus 1 by x dx. Okay, which can again be calculated using by parts. Fine. Moving on to the next question, which is our next passage, passage number 3. So for question number 32, we have given fx is equal to x square upon x square minus 1. So the function is not defined x is equal to minus 1 and 1. For simplicity, we can write it as 1 plus 1 minus 1. So 1 plus x, x square minus 1, and y dash will be equal to minus 2x upon x square minus 1 whole square. So y dash is equal to 0 at x is equal to 0. This will be a point of maxima. Okay, and we can draw the rough graph of rough sketch for this for its graph. Let's see. At x is equal to 0, y is equal to 0, and when x is positive, the function will decrease, and when x is negative, the function will increase. So clearly this would be between minus 1 to 1, and when x tends to minus 1 from positive side, y is tending to minus infinity. Okay, and when x tends to minus 1 from negative side, y tends to infinity. Okay, so see, the graph would be this, and this is an even function, so we can take the image, and now we can answer the questions. We can comment on its injunctive onto into nature from the graph itself. This is minus 1, this is 0, this is 1, and this is 1. Fine. Moving on to our next question, question number 35, 36, 37, pertaining to passage number 4. Okay, so we've been given a cubic polynomial 8x cube. So if a is equal to 1, fx will be equal to 8x cube plus 4x square plus 2bx plus 1. Okay, so f dash x would be 24x square plus 8x plus 2b, which would be equal to 12x square plus 4x plus b. So for fx to be increasing, f dash has to be greater than 0. So 12x square plus 4x plus b greater than equal to 0 for all x belongs to R. Then d has to be less than equal to 0. This implies 16 minus 48b is less than equal to 0, or b is greater than equal to 1 by 3. Okay. So question number 36, if b is equal to 1, y is equal to fx is non-monotonic, then sum of all integral values of a. Okay. So if b is equal to 1, fx becomes 8x cube plus 4ax square plus 2x plus a. F dash x would be equal to 24x square plus 8ax plus 2. Fine. So if for non-monotonic, f dash is equal to 0 must have distinct roots. Okay. Then d should be greater than 0 for this. This implies 6a square minus 48 greater than 0, or a square is greater than 3. Okay, or mod a is greater than root 3. So the values of a between 1 and 100 satisfying this would be 2, 3, 4 dash dash up to 100. So our required sum would be summation of k from 2 to 100. Okay, Moving on to the last question of this passage, question number 37. If the sum of the base 2 logarithms of the roots of the cubic fx is equal to 0 is 5, then the value of a is. So suppose okay, so suppose x1, x2 and x3 are roots of fx is equal to 0. Then we have given that log with base 2 x1 plus log to the base 2 x2 plus log to the base 2 x3 is equal to 5. So x1, x2, x3 is equal to 2 power 5, which is 32. But according to the equation, x1, x2, x3 is minus a by 8, which is product of roots, and hence a is equal to 2 power 8, which is minus 256, which is our answer. Okay. Moving on to the next question, which is matrix match. Question number 38. So for calculating first part of question number 38, we can see that root 2 plus 1 and root 2 minus 1, so we need to find the value of the integral. Root 2 minus 1, root 2 plus 1. Okay, so this is equal to x square plus 1 whole square minus x square minus 1 upon x square plus 1 whole square root 2 plus 1 dx is equal to this would be 1. So integration of 1 would be 1 from root 2 minus 1 to root 2 plus 1 would be 2 minus integration of root 2 minus 1 root 2 plus 1 x square minus 1 upon x square plus 1 whole square dx. So if we put x is equal to 1 by x in this integration, let's see what we get. This would be root 2 plus 1 and root 2 minus 1, 1 by x, 1 minus x square upon 1 plus x square का whole square, and x square cancel out each other, which is with a minus sign. Okay, so if this is I, this would be minus I. Okay, so if this is I, this is minus I, and both are equal, so I has to be 0 if I is equal to minus I, so the answer would be equal to 2. Okay, let's move to B part. Fx is equal to x power 1 by ln x. So f dash is equal to 0. F dash is equal to 0. Fx, so domain of f is 0 to 1 and 1 to infinity, since the domain of ln is 0 to infinity, and x cannot be 1 since ln x is in denominator. Okay, so ln of fx is equal to 1, and this implies fx is equal to e, which is a constant. Okay, f dash x is equal to 0. So if fx is equal to constant, then fx is equal to constant, f dash x will be equal to 0 for all x belongs to 0 to infinity within its domain. Okay, moving on to next part, part C of question number 38. It says the cosine of angle of intersection of the curves fx is equal to 2 power x ln x and gx is equal to x power 2x minus 1. Okay, so using hit and trial we can see that the point of intersection of these two curves would be 1 comma 0. That's quite easy. Now to calculate angle of intersection, we would calculate slope of tangents to these curves at M. So f dash x at 1 comma 0 and m2 would be equal to g dash x at 1 comma 0, and if we have calculated the slope, now the angle of intersection can be calculated as angle between these two lines, m1 minus m2 upon 1 plus m1 m2 given by tan theta. Okay. If h is the number of horizontal tangents and v is the number of vertical tangents to the curve this, then the value of h plus v is equal to this. So for this we need to calculate y dash. So let's differentiate d part. 3y square y dash minus 3y minus 3x y dash equal to 0. This implies y dash equal to y upon y square minus x. So y dash equal to 0, this implies y equal to 0, for which there is no real x, and y dash equal to infinity. This implies y square equal to x. This implies y cube equal to 1 and y equal to 1. Okay, or y equal to 1. So if y is equal to 1, we can calculate the value of x. It would be x equal to 1, hence the point will be 1 comma 1. Okay, moving on to the next question, question number 39. So if portion of tangent at any point on the curve this between the axes is divided by the abscissa of the point of contact in the ratio n externally, then n plus m is equal to. So for this, first we calculate dy by dx as dy by dt upon dx by dt is equal to 4t by 3. So the equation of tangent would be y minus y1 is equal to m x minus x1. Okay, its x-intercept would be y0, then x-intercept would be 80 cube upon 4, and y-intercept would be minus 80 power 4 upon 3. Okay, so the portion of so the point of intersection of tangents with the axes are 80 cube by 4 comma 0 and 0 comma minus 80 power 4 upon 3. Okay, so now we can calculate the point. If the point a t power 80 cube by 4 comma 0 divides the point 0 comma minus 80 power 4 by 0 and 80 square comma 80 power 4. Now we can easily calculate the ratio in which the point this divides this and this. Okay, moving on to the next part number B of this question, moving on to part B of this question, we get dx by dy equal to e power sine y cos y. So slope of normal would be okay. So if slope is known, we can write the equation of normal x plus y is equal to 1. Okay, but we need to calculate the area of triangle formed by normal at the point this. So clearly the area would be half into 1 into 1, which is half. Okay, moving on to the next part number C. If the angle of intersection of the curves this and this at the point this is theta, then tan theta equal to, so we'd calculate f dash at 1 comma 1, which would be m1, and g dash at 1 comma 1, which would be m2, and we can again find the value of angle of intersection of these two curves as m1 minus m2 upon 1 plus m1 m2, which would be given by tan theta. Moving on to part number D, the length of subtangent. So the length of subtangent would be equal to, for any curve, this is the length of tangent and this projection is length of subtangent. So if this is x1 y1, this is going to be, if this is x1 y1, this is going to be y1. Okay, and this would be y1 upon tan theta. So we already know, let the point on this curve be x1 comma be x1 by 3. Okay, so upon tan theta. So we need to calculate this. We already know tan theta. Tan theta would be y dash at x1 comma b e power x1 by 3. So if we calculate y dash at this point and substitute that value in this, we will get the value of the length of subtangent at any point on the given curve. Okay, moving on to the last question of this exercise, question number 40, which is again a matrix match. Okay, so fx we have been given y is equal to fx plus 1 by x. Okay, so let's see, fy, f of fy plus 1 by y is equal to 1. Okay, so this implies fx fy is equal to 1. So therefore fx is equal to f of fy plus 1 by y, 1 by fx plus 1 by fx plus 1 by x. Okay, and so if fx is equal to this and f is increasing, so we can say that x is equal to 1 by fx plus 1 by fx plus 1 by x, or fx is equal to 1 plus minus root 5 by 2x by 2x. Yeah. Okay, so if we have calculated fx, we can always comment on its maximum value in 1 and 2. We can calculate f of 1. We can also integrate fx from e to e square. Okay, thank you.